Yo, so today I will discuss with you how you can decrease your Docker image size up to 90%. So let's get started. So Docker file is used to create and build the Docker image. You all and I also know this. But if I use a regular Docker file, it will create Docker image around 800 MB, 1 GB of size. Okay, so that's where a multi-stage Docker file comes into the picture. We can use multi-stage Docker file to reduce the image size. Okay, so let's discuss why we should use multi-stage Docker file to create a Docker image. First of all, smaller image size. So it will split the build process, and after the build process is done, the necessary files are copied into the final image, right? And that eliminates the build dependencies. Like we don't need the dependencies and libraries into the final image. It will actually deletes the build dependencies, and it will reduce the image size. Now, improved security. So if I deleted, if I delete those build files, so it will just delete all the dependencies and libraries, right? So the sensitive data which will require to expose, that will no longer needed, right? So in the production image, which will be the production image, it will have minimal binaries and libraries which are more secure. So it will reduce the surface attack. Optimize for production. So if I use normal image in the build and alpine image in the production, and copy from the production image, copy from build image, and just use the alpine image. So alpine image means it will have minimal size of base image. So generally in alpine image we can manually install the build and dependencies. We have to manually install build and dependencies because it doesn't have binaries and libraries. It has minimal. Normal base image is In normal base image it has binaries and libraries to run the application, but in alpine image those are more, what I can say, more smaller in size. So it have minimal to minimal, next to 10% of the base image it have. Okay, so you can use a lightweight base image. As an example, alpine image. You can use also small image for the final stage, and resulting in a more minimal and streamlined production environment without necessary build tools or dependencies, right? So cleaner code structure. So multi-stage builds allow a cleaner and more structured Docker files. So in first stage we will build the image, and we will install dependencies whichever is required for the application. And after that, we can isolate the different process. So in a build process, we can use testing process, and then we can use the production process, right? So it will separate the stages. So it will more clear to a uh, a tester or a developer to check the which is necessary part of a image which is required to run the application, and it will improve the readability because it will structurized, right? So first in build and then test and then production. So it will structurized the uh, Docker file. Now it will readability, improve readability and maintainability. It will we can maintain also. So now I will go in straight to the VS Code, and I will show you how to create. Okay, so first I will create the normal Docker file, and after that I will show you how you can decrease the image size. Okay, so now I will use a Visual Studio Code. Okay, so uh, let's create a new folder. Open, not open file. Open folder, open folder. Okay, I will create open folder. So let's create a new folder. A new folder will be multi-stage Docker file. Right? Multi-stage Docker file. I have caps lock on. That's not an issue. And select folder. Okay. And now, so I I have to have a application to create a Docker file, right? So I have a Flux application which is running on Python, right? So this is a Python application. Flask is a Python application, you know, I think you know. So it will import the Flask and render template. So where is the template? This is the template. So this is the index.html file. So it will just return this is a Flask application. I will show you. Okay, so I have to open a new terminal. I will increase the font size. I hope you can see this. So I will just create, I will clone the Git. So Git clone and copy the Git repository, right? And it will just clone the Git repository. So you can see this that there is a Flask application. You can ignore this. Now I will change directory to uh, is it okay? I think it is okay, right? I think it is okay. Okay, so change directory to Flask application. You can see there is a app.py, requirements.txt, templates, and static web page. You can ignore the static web page because in static web page there will be a directory page. Okay, so this is an application. So let me try to run this application on my local I mean in locally. So what will I will do? Python app.py. It will just run the application on localhost colon 5000. Because why 5000? Because Flask application generally or defaultly run on port number 5000. So localhost 5000. Okay, so this is a Flask application, and you can see the template is a sample Flask application, right? Now I will just uh, end this process. Now if I do localhost my application, you cannot see any application run. Now let me create a Docker file. Just a simple Docker file. I will create some simple minimal Docker file for running this application. So Docker file. Now the Docker file, first what should we do? First I will download the base image. So I will use the base image. We can use Ubuntu image, or I will directly use the Python image. Now from sorry, from the base image name will be sorry. Um, the image name will be Python colon latest. I will install the latest one, and now I will create a work directory. So the all I mean these things, static page, index.html, app.py. Okay, it is creating on the templates page. Sorry, that should not happen. It should create on Flask application. Okay, so Flask application, and under that, I mean Flask application folder. Under that, I will create the Docker file. Now, uh, so first from base image will be Python colon latest. Now, I will set up a work directory. So work directory. Wait. Work directory. Um, let's say application. So I will just give an app. So it will create a folder. So under that folder, I have to copy the requirements.txt from here. So what should I write? I will use copy command. Copy source and destination. So what will be the source? Source will be requirements, requirements requirements.txt, and the destination will be, I use the work directory as /app, so it will copy on the /app, so it will just a dot. Now I will install, so I have to install pip. So using pip, not install pip, I have to install the requirements.txt, right? Requirements.txt. So how can I install requirements.txt? Using pip, right? So pip is a package manager of Python. Now run, I will just run. What will be the command? Pip install, right? What will be, what I will install? Requirements.txt. So hyphen r requirements.txt. Is that fine? No. I have to use no cache no cache directory. Why I use this? Because if I don't use no cache directory, it will just increase the directory size. I mean, increase the image size by using the cache. So for installing pip install requirements, it this command will just delete the caches which will be installed, which will be required to install requirements.txt. Now, so requirements.txt installation has done. Now what I'll do? I will just copy all the things. All the things means dot. All the things means requirements.txt, app.py, template, static, and you can ignore this. So where I should copy? I should copy on slash app. So all the things are running on the slash app location. So I have to copy from base image dot and then copy all the things to the slash app directory. Now to run the Flask applications, I have to set up an environment variable. So env, it will be flask run host. What will be the value? It will, so it will attach the host. So what will be the host? Host will be the local host. So I can use 127.0.0.1 or I can simply use 0.0.0.0. Okay. Now the Flask application, I have to open the port. So generally it will open the port 80, but I have to implicitly um, open the port 5000 because the Flask application is running on 5000. So expose, what will be the port? Port will be 5000. Now after that I will have to run cmd command. Why cmd command? Every time, if I run the Docker container, this command will be executed. So flask run. Just do this. I will save this. Okay, so let me check all the things from Python python latest work. There will be work directory will be app, copy from requirements requirements.txt. This will be fine. Run pip install no catch dir hyphen r requirement.txt. Copy all the things from source directory to destination directory, and I will set up the environment variables to flask run host flask run host is equal to 0.0.0, and I will expose the 5000 and Flask run. Okay. So Flask, comma. Right now, let's build the application. Docker build. I will tag it as a Python latest, and where will be the Docker file? The path will be the Docker file USB dot. Let's take a moment, and I think the Docker image has already done created. Now let's see the Docker image size. Docker images. You can see the Docker image is 1.3 GB. Now let's see that is this Docker image is actually running. Okay, so Docker run -d, it will run and detachable mode -p, I will port mapping with 5000 and container port will be 5000, and the image ID. It should run now. Okay, so the Flask application is running. Now I have to reduce these size, because in production if I use this much of size, it will just give me, I mean, use the lot of resources. So lot of resources means a lot of cost, lot of maintenance. So size will be small. Now ls. Okay. Now I will just use Python small image. Let's just search small image in Docker. So Python small image Docker. So if I go into the Python official documentation, I can have alpine images. Also, I should have a small images. Is it small? No. It is slim image. Sorry. It is slim image. We have also bullseye image or alpine image. So I will use slim image. Python 3.12 slim image I will use. Okay. So I will just use. So recent, what will be the recent one? 3.12. I can use also 3.13. Let's take 3.12. 3.12, and what will be the image? Slim. Yes, slim image. So all the things will be the same. So I will save these and I will write Docker build, build -t. I will tag the image as Python slim and dot. Okay, so Docker image has created. Docker images. You can see these that the image size reduced by 137 MB, and what is this 1.303 GB. Wow. So let's see, is it running? Oh, Docker run -d -p. I will map, what I will map, not 5000, 5001. Because why? Because let's see, if I use 5000, what will happen? And image ID will be this. It will give me an error. Why? Bind for 0.0.0.0 colon 5000 failed. Why failed? Failed is port is already been allocated, because the port is allocated to the main image, the latest image. If I do docker ps, you can see the port has been already used by this image, right? So I will use 5001. This just is should. Now I will just copy these and use 5001, and it will work fine, as you can see. Now 137 MB. Can I reduce more? Yes, I can reduce more by using Docker multi-stage. So I will just use, I have already copied this one. I have created these are the Docker multi-stage Docker files. Okay, so I will open this, open with Notepad. I will discuss this. Control C and Control V. Now, what is this? What is this? What? So, just I will use the from image. This is the, you can see, this is the build stage. I have commented this one, and this is the run stage. So, those two stages are different. After these stages, after this stage, this will delete it, and it will copy the build and the binaries and libraries from this image to this image, right? So I will use from Python 3.12. You can see, you can also use latest. This will also work as fine as builder stage, because this is build stage. We can specify this stage as a build. I use the work directory app, copy the requirement.txt, run pip install no cache dir r requirements.txt. All the things are same, copy all the things. Now now what are you happening? Now I will, sorry. Okay, now the second stage start running. In second stage, I will use from command and Python 3.12 alpine image. Alpine Docker image. It is the lowest possible image of Python. So from Python, 3.12 Alpine. I will just install the base image on Python, and after that, you can stay. This is a first stage, and this is a second stage. In first stage, in first stage, I'll just install the latest Python application. So it will have all the binaries libraries that is requirement to run any application. Now I install the pip install requirement.txt, all the build stages, and I'll just take some amount of that and copy to the Alpine image, because Alpine image has nothing. It's just a small image, a little image. So I will create a work directory application and copy from builder. Now from builder, what is from builder? It will just use this image as a builder, right? You can see that builder. Just in this build, from this build, I will just copy only the user local build Python 3 side packages, and I will just paste them. I will do the same thing for bin. So Flask, I have to use the Flask bin. I have just used the Flask bin packages, copy the bin packages and paste that. And all the things from builder, if from app. What is app? You can just copy these things. These things, what is these things? You can just go ahead and check that I have used work directory as app, and I have copied all the things. What is all the things? App.py, requirement.txt. You can just ignore this. We don't have to install copy these things. So the main thing is app.py and templates. You can just ignore these things also. Okay, so it just copy the app.py and templates from here to here, and do all the same thing. Just environment flask run.host, just set up the environment and expose 5000, and just use cmd command. Whenever I run the container, this command will run. So I will save this one. Docker build -t python, what is this, multi stage dot. Let's take a chance. Okay. You can see, you can see that what is that. Just take that. This is internal build stage, and cost things are copied, right? So I think it will run. So Docker images. Oh, oh, just 34 seconds ago, the size is 61.2 MB. What? Is this possible? From 1.3 GB, it just reduced 61.2 MB. Amazing. Let's try this application, right? So docker run -d. Okay, I have to take the docker image ID, na, right? Images. Oh, now docker run -d-p. I will map the port with 5002 because 5000 and 5001 is already used, and container port will be 5000. And the image ID, what will be the image ID? This one. This should work. This should work. Localhost 5002. And the image is already been working and the application is already been working. So docker image, docker, if I do docker ps, you can see the image ID. This one is running on 5002 and running fine. It's just running fine. If I go to static page, index.html, okay, it is not running. Okay, so static page, I have to see this one. Okay, the application, if I do here static, okay, it just copy the necessary things. You can see the necessary things are copied from static page. So if I want to copy the static page, I have to use that binary, static binary, right? So it will decrease and specifically use the application. Right? If I do static, it will not going anywhere. Okay, so how much reduced the image? 1.3 GB to 61 MB. So let's calculate. Let's calculate. Calculator. Calculate the percentage decrease. Now, 1 GB, what will be the equivalent of MB? 1 GB of memory, what will be the equivalent of MB? 100,024 minus 61 MB. Okay, divided by 1024 into 100. So 94%. Oh my God. 94% of reduction of Docker image. Amazing. So you can see that 94% of Docker image reduction we can do by using Docker multistage. So using Docker multistage Dockerfile, we can reduce the image size. Thank you. Bye bye.